and what are the conditions it should be operated. So now I would like to discuss what is a mission critical embedded system. Basically, embedded system, it will have several applications. But what is mission critical? A mission critical system is the one, if at all it fails, the loss will be catastrophic. So the effect will be catastrophic, such as severe injury or loss of life, or environmental harm, or damage to the system, lot of resources wastage, or financial loss. Anything which is very hard and difficult to recover back. That is the mission critical embedded system. So the mission critical embedded system is the one which should perform, which should have a zero failure and perform as expected in a very strict real-time requirement. So what are those applications? Aerospace, defense, medical devices such as CT scan, MRI scan, environmental monitoring. Example, if we go for medical devices, the CT scan, MRI scan, or the any health monitoring device is very important to save the life. So if these systems failure, a human life will be at stake. So that is why it is very important to build a system with 100% success rate. Though while building an embedded system, which is a combination of hardware and software, it is very difficult to achieve 100% success. But it is not impossible. There is possibility that we can build a system with 100% success if we follow some disciplined manner in the product development. So what are the key parameters we have to consider while building these systems? Yeah, the key considerations are, first, the very important thing is we should be clear about what is required, what we want to do. So the clear requirements are very, very important and the crucial step and the very first step to be considered while building an embedded system, followed by choosing the right hardware, choosing the right software development process, and designing a very good architecture, followed by the choosing of real-time operating system. So need not the real-time operating system is necessary for an embedded system always. So it can be an option also. So whether to choose RTOS or to go for an embedded system without an RTOS, that depends upon the need, what you want to build and what is the timeline you want to achieve. So finally, your requirements only will decide what things you have to select, and everything should be within the budget as proposed by the project. So cost planning is also very important aspect in building an embedded system. Followed by testing, which we cannot deny. Testing is one of the most crucial steps in ensuring that the system meets its required performance. And quality assurance, which plays once again a crucial role right from project planning to the customer deployment. The quality assurance or the quality process is involved right from developing the project, right from starting the development of the system till deploying, and post deployment also the quality plays very crucial role. So these are all the key considerations we should consider where multiple resources are used, different expertise is used, like software team, hardware team, testing team, quality team. Everyone, each and everyone will play a very crucial and important role in building a reliable embedded system. So now coming to clear requirements. Why clear requirements are important to us? Because if we don't know what we want to do, we can't achieve what we want. So before starting anything, requirements are clear. Example, if we know what is the speed we want to achieve in building, if we want to build an embedded system, and if we want to know within what time it should be completed, then choosing the right hardware with the proper configuration is very important, as well as choosing the right software is also very important. So the requirements should be very clear in choosing the rest of the components required to build an embedded system. So cost planning. Every project will have some cost to be achieved. So we can't build a system without any cost planning. So the cost planning plays an important step in selecting the right components. There are n number of hardwares available in the market. like microprocessors, microcontrollers, n number of autos, n number of software development life cycles, quality tools, IDEs required to develop the code, n number of projects. But how do we choose those projects? Everything is good at its own phase, but everything we can't afford, and every thing should be selected within the cost what we can afford. So the cost planning is also very important if we are aiming to build a reliable embedded system. Yeah. So now choosing the right hardware. The hardware is the core component for any embedded system. So whatever the software we develop, it finally goes onto the hardware. So the key parameters to consider while choosing the hardware is processing speed, latency, clock, the memory, how much memory we want to use for our system. So in some critical applications such as defense, aerospace, space is a key constraint for us. We can't deploy a very large size of hardware onto the aircraft. It's difficult and it's not practical to deploy a large hardware. So we want to choose the hardware which can fit within the aircraft. Like the final hardware where you are going to mount it on, how you are going to enclose the hardware to protect it from the environmental factors. So what is the impact if you mount it on some external device, how the hardware behaves. So all these factors should be thoroughly considered. So that is the scalability and upgradability. So what is upgradability? So technology keeps on changing very often. So what hardware today we might choose need not meet the requirement in our upcoming projects. So the hardware should be easy to get upgradability for n number of missions. So we will be doing n number of projects in a company. So the hardware should have the adaptability to operate for n number of requirements and projects. So that way you can consider the clock speed. The clock speed you can choose for different types of conditions, etc. So the complaints and certification. Whenever we choose the hardware or software, it's very important to get a secure and reliable and proven hardware. So how do we say it's in proven hardware or it's in proven technology? One way is the certification. The certification what we get saying that this has met the following standards. That is very important in choosing the right hardware. So coming next, the robust architecture. So a robust architecture incorporates redundancy and fault tolerance. So redundancy is always very important to be maintained in a mission critical application. If one system failed, there should always be a backup system to take over and cover the loss. So while designing the architecture, we have to consider how the system will perform, what is the stability of the system, how the system handles the data breach, and what is the future upgradation, quick troubleshoot, and the simplified testing. So the testing also should be easy. The architecture should be designed in a very modular manner so that the testing is quite easy to carry and the bugs can be easily identified. So these are all the important things to be considered while building a robust architecture. And the architecture should be built in such a manner that it should get easy adaptability from application to application. So if we want to build a new application with the existing architecture, so it should be able to do with minimal number of changes. Then only it will be time effective. Coming next is the software development. So as I have said earlier and everyone knew, embedded system is a combination of hardware and software. As important as hardware is, same the software is very important. And the hardware failures are relatively easy to spot because they can be visualized and they can be identified. But the software failures are not easy to identify. It's like imaginary. We have to visualize what has gone wrong. So while choosing the software development, I would like to say the software development lifecycle process and the tools what we are using to develop the software. Tools such as the IDEs, debugging capabilities and the compilers. All these things plays very major role in ensuring a successful software. So the no software will be 100% bug free, but whatever we aim to build, the software can be built with minimal number of bugs. At least it will perform as expected in the maximum operating conditions. That is what we have to aim while developing the software. So now while developing the software, what are the main challenges is involved? One of the main challenge involved in the mission critical applications is deterministic behavior. So what is deterministic behavior? Getting the results as expected consistently for the n number of runs. So the behavior should be always as predicted. It should not go unpredicted. So in the real-time system, particularly what makes embedded system so difficult is while building an embedded system, we have different types of interfaces involved. Electrical interfaces involved with it. Even a less minimal number of noise also can manipulate the data, which gives to the unexpected results. So all these very minute details has also to be considered very carefully. So that is why it becomes very challenging to get the deterministic behavior, and achieving this deterministic behavior in a limited resources. Example, if we have 1 MB of RAM, all your entire application is should be supposed to fit into that 1 MB of RAM. You can't exceed the 1 MB of RAM. So how do you make sure that your application fits into 1 MB of RAM? So that is where the requirements play a crucial role. The more aptly you design your requirements, the easy the process will be in developing the software. That is why requirements are very important, and the very first step to be considered carefully and captured carefully. Then comes the real-time timelines. So any embedded real-time system, almost all mission critical applications, 100% mission critical applications are real-time systems only. So they should operate within a defined time, and they should not respond beyond the defined time. If at all done, the loss is very huge. So meeting the requirement in the defined timeline is very important, and that makes the software very challenging. One is the deterministic behavior, second is meeting the requirement in the real time, and third one is the complexity of the system. So as a software engineer, in my experience, whenever we try to test a system, an integrated system, the results might not be as expected, and we are not sure whether it will be a software issue or it will be a hardware issue. So we have to look into every perspective. So if you are an embedded engineer, you should be very strong enough to detect the hardware issue as well as the software issue. Then only you can quickly assess the situation and fix the problem. So system complexity is also a very challenging thing in mission critical application. And finally comes with the compliance with the safety standards. So many mission critical applications such as the civilian aerospace industry, if they want to fly an aircraft, they have to get the certification from the certified agencies. So in order to meet the certification, it's very essential to follow all the safety standards. So our software should be compliant with the safety standards. So this is about the software development life cycle. And there are many different software development life cycles available in the market. Okay, so nothing, it's like we can't say this is good for this, this is good for this. So being as a project member and being as a team member, you should be able to analyze what method will suit for you. The method which suits for one application need not be that it will suit for another application. So what is your requirement, what is your timeline, and what is your process to be followed, that makes that gives you the input to choose which software development process you have to use. But following a software development lifecycle process is very much important, because it's like a guidance to us in which way we have to travel to meet our destination. So the next thing is the real-time operating system. So to guarantee the predictable and consistent performance in a critical embedded application, real-time operating system plays very major role. Example, if you have multiple tasks and if your system is intended to interact with multiple components in the external world. So all the I/O interfaces should respond as expected within the defined time. So the RTOS made sure that RTOS will sync all of these all of the interfaces as well as your task to behave as expected in the real-time world. It's like it schedules your system. So without operating system, also yes, it is possible. We can achieve it, but if we use RTOS, it is more predictable results what we get. So while choosing RTOS, what are the key characteristics we have to consider? First thing is the kernel. How secure is the kernel? So Linux, it's an open source. Some of the OS, VxWorks, QNX, they are proprietary. Everything is good, but you have to choose what are the key things you want to adopt for your project. So those things are the scheduling properties. What are the memory requirements? What is the processing speed you want to achieve? Connectivity of the RTOS system. So what is connectivity? How does your system interact with the external modules, or how does your system interact within itself? If you have multiple tasks, how your system will interact? One example is IPC, inter-process communication mechanisms like message queues. How well they are defined? Do they corrupt when multiple things comes into picture? How the content switching is happening. So everything before finalizing a thing, you have to do n number of test runs. You have to consider n number of cases for your application, work it, analyze the results, then you freeze the final RTOS, or you can freeze the hardware also. So before freezing the final components for your project, first do a well requirement analysis, do some test cases, perform the test cases, test scenarios, analyze the results, do the development on the prototyping things, and then you freeze your hardware and software, hardware component and your software process. Okay. So planning plays very important role in this complete chain. So next thing is testing. So testing, right, we freeze our requirements, and right, we freeze our software requirement specification. We can start working upon the testing cases. So testing makes sure that each and every module is designed to work as it is expected. So building n number of test cases and doing different levels of testing like unit testing, integrated testing, system level testing, all this process will help us for early detection of the bug, and it will save the resources, and it will save the time and money. So effective testing strategies, what does it involve? It includes defining test cases, executing the test cases, and defining the test cases for different levels like unit level, integrated level, software and hardware integration test, and finally after executing the test cases, it is as such as important that you collect all the test results and make a test summary report, consider the observations, understand them, and go and apply back in the designing process. This should be an iterative process such that your final aim should be that your test summary should have 0 observations. Till you achieve 0 observations, you should have that patience and discipline to follow this process. So challenges involved in testing is hard, particularly in embedded system, hardware dependency, integration of hardware and software, and the software getting updated regularly, or the software tools, IDEs getting updated regularly. So all these are the challenges involved in testing. So how can we avoid them? We can avoid them by following the configuration management. Example, if you are using an RTOS in your application, fix a version and across your team and the entire teams which are involved in the software, which are involved in the product development, stick to the same configuration, or everyone be on the same node. Testing guy use some version, development guy use some other version. So that leads to the that leads to the conflict situations. So maintain the configuration management. For this, there are many tools available, software management tools, and same way to maintain the quality assurance, Also, there are many tools available in the market, as today we are here for LDRA. So LDRA is also one of the testing tool and qualification tool which we personally are using at Skyroot, and we are satisfied with the results. So as a startup company, we are aiming to build a reliable system with 100% success rate by following the discipline and keeping the patience in following all these process and no compromise in any of this process. We are confident that we will aim to have 100% success in our upcoming launches. So I would like to discuss two case studies where if at all we do not follow this process, what could be the impact. So I would like to explain about this Ariane 5 rocket explosion. So this Ariane 5 rocket, it was a space launch vehicle which was designed to launch multiple satellites by the European Space Agency. So what happened to this? What caused this rocket to get exploded immediately after 37 seconds of liftoff? So this was, Ariane was a series of projects. So the Ariane 5 has reused the software from Ariane 4. Obviously the system requirements were different for Ariane 5 and Ariane 4, where the Ariane 5 velocity was very high. So when they have reused this Ariane 4 software into this 5 series, a conversion issue has happened in the inertial reference system, which used to, there was a conversion issue where a parameter was converted from 64-bit floating point to a 16-bit signed integer, and that value was beyond the storing capability of the 16-bit signed integer, which caused in stack overflow, raising to an exception. So as there was no exception handling mechanism, that caused in the loss of the navigation, guidance and control system, which led to the vehicle to get deviated from the trajectory, and unfortunately the rocket has to be destroyed using the destructive command. So what caused this issue? If at all, if we want to reuse anything from a previous project also, though that software worked well for the previous version, it is not mandatory that it works for our current version. So we have to follow a strict testing and QA process. And for every software, as though it gives the 100% expected results, a good exception handling mechanism should always be destroyed, should always be considered. Example, a very small module also, a small filter designing also. If in control, you're using some filters, and it can be a simple low pass filter. But what if that filter doesn't work properly? What is the action to be taken if that filter function fails? So each and every function should raise an exception if at all it fails, and that exception should be handled properly by the software. So that is very important. So the main reason in this case study was ignoring the software testing and QA process resulted in this failure. So the second one is, what if the inherent mission requirements are being captured? If the mission requirements are not analyzed properly, what will happen? So this case we can understand by Mars Polar Lander. It's a Mars surveyor which was developed by NASA to study the Mars surface. So there were the landing legs, and it has caused due to premature engine shutdown. So what caused this engine to shut down without touching the land? So the landing requirement was captured such that whenever a vibration is sensed by the sensors, the lander assumes that it has already touched the ground, and it leads to the engine shutdown. But what actually happened? Before touching the ground itself, an erroneous vibrations have raised while opening the legs from the lander. That vibrations was mistakenly understood as the lander has already touched the ground, and the engine shutdown command was issued. It could have been corrected if they had a redundant option. So sensors are always subjected to very minor effects also. So if they could have kept a redundancy detection mechanism, like by using the height sensor to detect how much height the lander is from the vehicle, that would have saved the mission. So capturing the correct mission requirements and having a redundant mechanisms for the success rate, it is also very important. So this Arrange 5 was one of the very most Arrange 5 was very important in the software field industry, which has alerted everyone how important the testing and QA process, and this incident has led everyone across the globe to follow a very strict QA and testing process. So yeah, so thank you from our team, Skyroot.